Hey, welcome back, Matadors. This is Mr. Science. We're going to start reviewing Chapter 2, Lesson 5. So we're approaching the latter part of the chapter. The title of this lesson is called Similar Figures. So the essential question is, how can you use proportions, so this is a key word here, proportions, to help make decisions in art, design, and magazine layouts. So we've all cropped photos, inserted photos on documents, and you can adjust those photos, right, by touching the corner of the photo, right, and dragging it out. And when you drag out the photo, you keep its original size proportional, right, as you drag it out from the corner. Now, if you look at these different images here of these monkeys, if you look at the original photo first, in the upper left-hand corner, okay, that's the original photo. Please give me your full attention because we don't have any time for monkey business right now. Ha ha ha, some quarantine humor. But this is the original photo here. If you were to just click, if you were to just click on the side and drag it out, it would make the monkey appear to be wider than what it is, right? So that this image here is not proportional to the original photo in the upper left-hand corner. And same rules apply if you were to click on, let's say, just the top of the image and slide it up, then the monkey would become elongated, right? He looks completely different than he does in the original photo. But if you grab a corner and you slide it out, you drag it out diagonally, then the picture proportionally gets bigger, right? And you could do the same thing in reverse and proportionally shrink the image where it does not distort it, but it keeps it the same, but a different size. Okay, that's similar. Okay, that's the key word. The word of the day is similar. Okay, so remember, similar is close. Similar is close, but not exactly the same. And let's go ahead and let's continue moving on. So we have focused on congruency and how figures are congruent. Remember, congruency or congruent means that the shape or the figure is the same and the size is the same. So it's exactly the same, right? And that's congruent. But now I want to refocus our attention on similar. Okay, so when shapes are similar, when figures are similar, that means they're the same shape, right? They're the same shape, but they are in a different size. Okay, and they are proportional. So same shape, different size, but the shapes are proportional to one another. Okay, so similar and proportional are a couple keywords that I want you to remember as we progress through this lesson. These are some examples of proportional shapes. So here you have two squares. One square, the little square, the baby square, is 1 by 1, right? And if you look at the mama square or the papa square, the bigger one, it's 2 by 2. So what did we do to the original square to make it into the larger square? Well, all we did was what? We multiplied it by 2, right? Each side got doubled. So that's how you can see that the squares are proportional, because one is half the size as the other. The circles. Okay, let's go ahead and take a look at the circles. Now the circles are similar, but they are not the same. Obviously, one circle is way smaller than the other, right? And if you look at these triangles here, these triangles are equilateral triangles. You can tell by the hash marks, right, that every single side on the little triangle is the same length. And you could tell on the bigger triangle that every single side is the same length, so both are equilateral triangles. That means that their angles are all 60 degrees, which means that those triangles are similar. Now, they're not congruent because they're different sizes, but they're similar because they are the same shape. Okay, here's another image we can focus our attention on. So these two triangles are similar. We have triangle ABC and triangle DEF. If you look at a triangle and you want to know if it's similar or not, you have to look at the angles first. Now, if you look, angle B and angle E are congruent. That's why they have one ring. Angle C and angle F, they are congruent. That's why they have two rings. And angle D and angle A are congruent. That's why they have three rings. So you have two triangles of different sizes, but their angles are congruent. That means that those two triangles are similar. So two figures are similar when their corresponding side lengths are what? Are proportional. So the corresponding side lengths are proportional. So AB and DE are proportional to one another. Okay, BC and EF are proportional to one another. AC and DF are proportional to one another. Corresponding and angles are also congruent, and we already reviewed that. So corresponding angles are congruent. So like we said, B and E are the same. A and D are the same. And C and F are the same. Okay, so when the side lengths are proportional, this is what that means. Let's say this is 1, this is 2, and this is 3. And we tell you these triangles are proportional, and I give you that this is 3. How do we get from here to here? What do we multiply by? We multiplied by 3. So that means the bigger triangle is 3 times the size of the smaller triangle. So what value would go here? What do we do with this 2? We would also multiply it by what? So this would be 6. And what would the value here be? What would we do with that 3? All we do is we multiply it by 3. Right, and this is just kind of a quick overview of showing you how triangles can be similar, how figures can be similar. So we know the smaller triangle here is about 1/3 of the bigger triangle. So the ratio you would use is, well, 1/3 or 3, depending on which way you're looking at it. Moving on. So identifying similar figures. Okay, identifying similar figures. So which rectangle is similar to rectangle A? So we're going to go ahead and we're going to focus our attention on rectangle A. Okay, and we're going to see which of these rectangles is similar to A. So all 3 figures are rectangles. So all angles are congruent, right? They're all 90-degree angles. All 4 angles of those rectangles are 90-degree angles. We need to check to see if the corresponding side lengths are proportional. So what are the corresponding side lengths? Well, we have lengths and widths, right? Lengths and widths. So we want to see which ones are proportional to rectangle A. So let's go ahead and let's put the length of rectangle A, the width of rectangle A, which is what? 3. And what's the length of rectangle A? 6. So we have our proportion, right? The proportion of the width So we have the width over the length. The proportion of the width over length for rectangle A is 3/6, or you can simplify that to what? To 1/2. So what we're looking for is this ratio between rectangle B and rectangle C's width over length. So let's go ahead and look at rectangle B. Its width is 2. Its length is 6. So what is its simplified ratio of width to length? It's 1/3. So is that similar? Is that proportion? Is that the same ratio that you get? Are these two ratios the same? No. So rectangle B cannot be a possible solution. Let's take a look at rectangle C. Well, its width is 2, its length is 4, and if you were to simplify that ratio, it would be also 1/2. So you know that because they have the same ratios of their corresponding side lengths, C is similar to A. Moving on. So finding an unknown measure in similar figures. So you have two triangles, they are similar. Now if they do not tell you that they're similar, then what you're going to want to look for is the rings to make sure that they all have the same amount of rings in the corresponding angles. Okay, but for now, the triangles are similar, and what you need to find is the x. So what are you looking for? Well, you're looking for the ratio, right? You're looking for the ratio, you're looking for the proportion of their corresponding sides. So let's go ahead and let's take a look at the first triangle, and we have two sides of the triangle, right, that are given to us. We have the left side, right? We'll say it's called the left side, and then we have the right side, and this is just for identification as we write. So we're going to put the left side over the right side in our proportion. So we're going to say it's going to be 6/8. And what about the other triangle? The other triangle, well, the other one has a 9/x. Okay, and we'll come back to this one in a second. But let's focus our attention on this 6/8. What can I do to that 6/8 to make it a little easier for us to do some math with? Well, if I divide both by 2, I can reduce it down, right, to 3/4. And now that I have my two ratios, my two proportions for my two similar figures, I can put them together. And I can say 3/4 is equal to 9/x. And remember, I can cross multiply and solve, or all I have to do is just scale, right? And how do I get from 3 to 9? Times 3. How do I get from 4 to x? Times 3. So what is x? 12. So the missing side length would be 12. Now let's say you don't like to do scaling. Maybe you look at it this way. Let me slide him over. Maybe you look at it this way. You have your 3/4 equals 9/x, and you do that cross-multiplying method, right? So we're going to multiply 4 times 9, so we get 36, and then we get 3 times x, which equals to 3x, And then just basic algebra, right? You divide by 3. Either way, you get 12 equals x. So either way, if you want to cross multiply to solve, or if you want to scale to solve, it doesn't matter, as long as you're finding the correct solution. But the key here is setting up your proportions, right? That's the key. And that's it for our notes for Chapter 2, Lesson 5. If you need to rewatch it, please do so. If you need to peruse at a certain speed, please do so. But enjoy your day, and I hope all is well and your families are healthy. You are missed. Take care.